Determine whether the triangle with vertices A, 4, 5, B, 1, -6, and C, -3, 2, is a right triangle. Here there are two methods that we can use. The first method will use the slopes of the sides. For this, we will use the slope formula. The premise here is that for a right triangle, two sides must be perpendicular. The slopes of perpendicular line segments must be negative reciprocals of each other. For example, consider a slope of 2/3. The slope of a line perpendicular to this must be -3/2. Note I've taken the reciprocal of 2/3, but also inserted a negative sign to make it the opposite and the reciprocal. Point A at 4, 5, point B at 1, -6, and point C at -3, 2, drawing a triangle between these, we can see that angle C is going to be the right angle if this is a right triangle. Finding the slopes of line segment, first of all, AC, we take the change in y coordinates divided by the change in x coordinates. This results in 3/7. Then we look at line segment BC and find its slope, the change in y coordinates over the change in x coordinates. This is equal to 8/-4 or -2. Note here that the slopes are not negative reciprocals, therefore we can say that this is not a right triangle. The second method will use side lengths to determine if it is a right triangle. For this question, we will have to use the distance formula. The idea here is that a right triangle must satisfy Pythagorean theorem. C² = A² plus B². Note that for this question, we do not need to find the actual side lengths, but instead we can compare the squares of the side lengths, since all of the variables involved in Pythagorean theorem are squared. Note that the sides must be labeled based on the opposite angle. We have opposite to angle A is lowercase a, opposite to angle B is lowercase b, and opposite to angle C is lowercase c. Note here that the hypotenuse, if this is a right triangle, will correspond to side C. Let's find the lengths, or at least the squares of the lengths for sides C, A, and B. First of all, for C, C² is going to be equal to the difference in the x coordinates squared plus the difference in the y coordinates squared. This gives 3² plus 11², or 9 plus 121, which is equal to 130 for C². For A², again, we square the difference in the x coordinates, and then we add the square of the difference in the y coordinates. This gives -4² plus 8², or 16 plus 64. This is equal to 80 for A². Then for B², the square of the change in the x coordinates plus the square of the change in the y coordinates. This gives us 7² plus 3², or 49 plus 9, which is equal to 58 for B². Note here that A² plus B² is equal to 138. C², however, is equal to 130. Since C² is not equal to A² plus B², we can now say this is not a right triangle.